Hello, I'm Kay Crail, and in this demo I will present you with an application that targets two DSPs and two FPGAs. The DSPs are on the SMT395 and SMT387 modules. One of the FPGAs is an attached FPGA on the SMT395 VP30 module, and the other is on the SMT368. This is a reasonably complex application which uses many resources, and I hope that you have already seen the previous videos, as some of the knowledge on how PARS works is assumed in this video. This is a filter application that we are trying to develop here. Let's begin by opening the Simulink model of the application. By clicking on the host subsystem, we can see that there are two signals generated in this block and combined before sending it to the inputs of the next subsystems. The same combined signal is also sent to a scope. By clicking on various subsystems, we can see what each one is designed to do. Note that on the upper part of the model there is an FPGA task which performs a filter operation, while the lower part of the model has a FPGA task which does an add operation. In this case, there is another signal generator which feeds into the add block. The signal is generated on a DSP rather than on the host. Note the channels shown on the Simulink model. In order for PARS to create these channels on the available physical links, we need to click on the config block mask and choose End of Configuration File. And then in the window, type on which wire PARS should place each channel. Click Apply after all channels are mapped to physical wires. Save the model and then Start Simulation under Simulink. Click on the host subsystem to display the scope, and we should see the output of the original, the filtered, and the added signals. Stop simulation and start PARS. Open PARS and select the target hardware as SMT395 plus FPGA plus 368 plus 387 and select Sysgen as the FPGA task generator before accepting the setup. Now open the model in PARS. Starting from the top blocks, select each one of the subsystems in turn and let PARS create the task targeting a DSP, FPGA, or host as appropriate. Note that any FPGA task communicating to host must have a DSP task in between the FPGA and the host. Don't forget to change the FPGA tasks from root to the appropriate target FPGA. In this example, we put the filter FPGA task on the attached FPGA and the add FPGA task on the SMT368 module represented by FPGA 350. Note that we are also using multi-DSPs in this demo, so we are assigning one of the DSP tasks to DSP B as shown. We could have put more than one task on DSP B if we had wanted to. Save and then press the yellow button as before. PARS will generate the application containing all the code for DSPs, the FPGAs, and all the booting information and communication before displaying a test bench. In MATLAB window, we could see the progress of PARS. This will take some time as it has to generate the necessary codes for 2 FPGAs. You may want to fast forward at this stage. Finally, PARS will report success and press OK. Open the test bench and run the application as seen in the previous demos. It should display the 3 signals on the scope as seen under simulation. Thanks for watching this video. We appreciate it.